Oh boy, do you think I need a haircut yet? Well, one way to make things better is to do a little math, so let's try some out. Okay, looks like we have a particle in motion, and this is the graph of the particle's velocity. At time equals 0, the particle is, I guess it's on the x-axis, yep. The particle is at x equals -2, so here's the x-axis, and if that's 0 and this is -2, at time equals 0, so the particle starts right here. And so first of all, the velocity is negative until time equals 3. So let's say this area, so from 0 to 3, the area is 8, so this area is 8, but since it's negative, the particle moves in a negative direction. Looks like it's -10, right? And then the particle at time equals 3, the velocity is positive, and the area of that part is 3. So from here, at time equals 3, it moves to the right. 3 to -7. And it's there at time equals 5. And then it moves to the left because the velocity turns negative and the area here is 2. It moves to the left 2. So it ends up right here at -9. This is time equals 6. So at time equals 0, it's at -2. Time equals 3, it's at -10. Time equals 5, it's at -7. And then time equals 6, it's at -9. Okay, anyway, that's just stuff. Now we can figure out how to answer these questions. So for time equals 0 to 6, find both the time and the position of the particle when the particle is furthest to the left. Justify your answer. Okay. So we want to find the minimum position, okay? So the position is -2 plus the integral from 0 to whatever time we want to find the position of this function, v of x dx. Okay, so at time equals, I'm doing this again. Let's call the position x because it's on the x-axis, and we'll use a different variable here, like w. And I'm going to squeeze this, sorry. X of t. Okay, it's there. So x of, and the velocity equals 0 at time equals 0, time equals 3, time equals 5. Okay. Min occur So let's check those. X of 0 is -2. X of 3 is -10. X of 5 is -7. X of 6 is -9. Particle is farthest left at time equals 3. X of 3 is -10. Okay? So that's when and where. For how many values of t is the particle at -8? Well, it's at -8 once between time equals 0 and 3, once between time equals 3 and 5, and once between time equals 5 and 6. So the answer is 3. Three. Time equals 0. And time equals 3. Is that the intermediate value theorem? Okay, I think that's all you have to say. This is true because the function is differentiable, which makes it continuous. Okay, that's no, anyway. So let's see for C on the interval 2 to 3, and the interval time equals 2 to 3. Okay, the speed of the particle, is the speed of the particle increasing or decreasing? So remember the deal with that. Between 2 and 3, between 2 and 3, the velocity is negative since the velocity is below the x-axis. I'm going to pause.